Hello everyone, and thank you so much for joining me. If you've watched all my other videos about the four operations, we have come to this point now where we're going to learn about ways to divide. There's two ways that I know of as far as ways to divide with just numbers and calculation. Okay, the first one is called partial quotients. If you've seen my other videos, you know that this idea of partialness is really big in education nowadays. So we try to find the parts of numbers to get to the actual answer. The second strategy is the standard algorithm. Otherwise known as long division. Okay, let's get to it and let's take a look at some examples. Okay, so the first thing that we need to know are just different ways that division looks. Division can look in so many different ways, all right? It can look like this, 23 divided by 8 equals. It can look like this, 23 divided by 8 equals. You can express it as a fraction, 23 divided by 8 equals. Some people like to write it like this. Okay, these are all different expressions to try to figure out the same answer. The most important thing that we know is what the numbers are, okay, and what they mean in relation to the problem. So in this case, 23 is the dividend. The dividend is what you're actually dividing into different parts. Okay, if you saw my video with ways to think about multiplication and division, that's a good idea to do that at this point. Okay, before you get to here. So 23 is the dividend, that's what you're going to divide. 8 is the divisor. Divisor. The divisor is what you're going to be putting the dividend into equal groups. Okay, the answer is called the quotient. And quotient is a fancy name to say answer for a division problem. Okay, so in each one of these problems, the answer is 2 remainder 7. 2R7. Okay, and in this case, 2R7 is the quotient. So as long as you know these things here, that as long as you understand what a dividend is, what a divisor is, then you can understand what a quotient is. And it'll help you to be able to see all these different ways to express a division problem. Okay. Let's go ahead and take a look at the partial quotient strategy. Okay, with partial quotients, what we're trying to do is multiply numbers to get to the answer. Okay, so let's go ahead and take a look at an example. Let's go ahead and take a look at 54 divided by 6. Notice that when I do this, I make it really long here on the side. The reason I'm teaching partial quotients last, in fact, the reason I'm teaching division last, is because we're going to use all three of the other type of operations in order to solve this problem. Some of us can look at this and just know what the answer is now, but let's imagine that I don't. Okay, so one thing that I can do is I can start using numbers here on the side to multiply by 6. So I'm going to take 4 first. And I'm going to say 4 times 6 equals 24. This right here is a partial quotient. That's going to be part of my answer. 4 times 6 equals 24. Now I have to subtract this. 54 minus 24 equals 30. I'm getting closer to the answer. Once I can't divide into it anymore, then I know that's my answer. Okay? So at this point, I'm going to say, just kind of pretending that 3 is my next number. 3 times 6 equals 18. The standard subtraction algorithm with borrowing is important for partial quotients and also division too. So what I'm going to do, I can count up from 18 and add 12 to get to 30, but most kids really can't do that, especially when they're first starting, so we're going to use our bigger bottom, better borrow strategy. 10 minus 8 is 2. 20 minus 10 is 10. Now my last number here that I'm going to use is 2 times 6, which equals 12. Now I subtract it. I have no remainders. So now what I'm going to do is add all of my partial quotients here. 4 plus 3 is 7. 7 plus 2 is 9. That's my answer. (54) divided by 6 equals 9. If you want to get a little bit more fluency, write it like this. Okay, and if you are the type of kid that knows your fact families really well, then you'll understand this expression. Okay, so once again, 54 is the dividend. Six is our divisor. 9 is our quotient. Okay, that looks kind of messy, but you get the idea. So it's almost the opposite of long division when we get to long division. Okay, well, we're trying to figure out which numbers we can multiply the divisor by to get to the actual dividend. Okay? So, now if you know that 6 times 9 equals 54, then you can just go there. Divided by 6. If you just know it's 9, then just do 9. 9 times 6 equals 54. When I subtract that, it's 0. I have no remainders. So the answer must be 9. Okay? It's the thing that's cool about partial quotients is that you just use different multiplication basic facts that you're aware of, or just basic multiplication that you're aware of to get to the actual answer. You can go directly there, or you can use different partial quotients to get to that point. Okay, so let's look at some more examples. One thing that's awesome about partial quotients that I completely love is that it causes you to extend your basic facts. Okay, so I'm going to take a look at something like this. Okay. Now, it is similar in a way to long division, where you want to take a look at these numbers right here, maybe the first couple numbers, to get a good estimate of what you need to multiply 6 by. So I know that 6 times 9 is 54. And if I extend my basic fact to higher numbers, then I know that 6 times 90 is 540. You see? Okay, and if you take a look at my video, Ways to Multiply, the first thing that we do is fact extension exercises. Okay, if 6 times 9 equals 54, then 6 times 90 equals 540. When children just start learning, it's okay to count the 0. So I have my basic fact there, 54. I'm just adding a 0 at the end. That's okay to do. Okay, now we subtract 546 minus 40, and we have 6 left over. So now I'm going to multiply 1 times 6. 1 times 6 equals 6. 6 minus 6 is 0. I have no remainder. I'm going to add this up. 91. Okay? So now, again, I do encourage, because my students really don't see this. And in fact, I don't teach this to 3rd grade children. This is more like 4th and 5th grade. Okay, maybe even the end of 4th, maybe the beginning of 5th. And I have taught some 5th graders where it's a difficult strategy for them too. So this may not be the most developmentally appropriate strategy for a 3rd grade child. That's one of the reasons we don't teach it in 3rd grade. Okay, so keep that in mind. It does have 3 different operations. So you have to add, you have to subtract, and you have to multiply in order to set up the problem as well. So this is not an easy strategy, and it's going to take time. 3rd graders can get it if they practice hard at it. It totally is possible, but don't expect them to understand this. Okay, in fact, don't expect a 4th grader to understand this, or even maybe like half of a 5th grade class may not understand this. Okay, so it does take time, but it is worth it. If you practice, it'll definitely pay dividends. No pun intended. Okay, so now rewrite this expression, 546, the dividend, divided by 6, the divisor, equals 91, the quotient. Okay. Okay, this is all right to do. This is how my students are used to seeing it. If you want to write the expression as a fraction, you can do that as well. Okay, the most important thing to remember, like I just said, is to understand what each part of this division problem looks like. Okay, just kind of reviewing the way it may look. If you took a look at my my video, ways to think about multiplication and division, okay, I taught the idea of a sharing mat. And I'm not going to go through the whole thing, okay? That's not the purpose of this video. But you would have a total of 546 something, okay, whether it's beans, whether it's rice, whatever it is. And then you would share them equally into 6 equal parts. Okay? This is the concept behind division, or at least this is one concept of division. Equal sharing, okay? So if I were to share them equally, I would have 91 in 6 equal groups. You understand? And if you wanted to bust out, not bust out, sorry. If you wanted to get out some rice, if you wanted to get out some beans or whatever and put 546 of them out there, and you wanted to put them into 6 equal groups of 91, you can. It might take you a while, but it is possible. And you would find, if you don't lose count, you'll have 91 each in each one, okay? So, but obviously we want to make that shift from understanding conceptual division, okay, to actually working out the division problems with numbers, okay? All right, so you get the idea of partial quotients. Now let's practice. I will say that, I will say for partial quotients that, or when you're dividing on I wouldn't use this necessarily for division unless you have you have some sort of, as long as if your calculator can show you the remainder correctly. Okay, in this case, it's going to show the decimal. All right, don't let that, so if you don't have the right calculator for it or the right settings to show the remainder, don't use it. It will confuse a kid. Okay, so for this exercise, I wouldn't do that. All right, I'll show you a different way where you can actually figure out if you're correct or not, okay? Partial quotients. I love just to kind of make up problems. So I'm going to say something like 85 divided by 7. Now I'm going to use what's called a friendly number, and a friendly number is a number you can use to get you very close to the actual dividend. Okay, and I know 10 is definitely a friendly number because anybody can do 10 times 7. 10 times 7 is 70. When I subtract that, okay, I have 15 left over. Now I'm going to do 2 times 7. 2 times 7 is 14. With a remainder of 1. This is your remainder. This cannot go equally into groups. It can, but as a fraction or as a decimal. All right, it would be the number 1 divided into 7 equal groups, and that would be less than 1. Okay, that's an advanced way of thinking, but it is true that we can divide it equally into 7, but it's not going to be a whole number anymore. It won't be a whole number. Okay, so what I like to do if I have a remainder is I actually like to write it right here, R1. okay? That makes it a little bit easier for me when I add it. So I'm going to do 10 plus 2 is 12. 12 R1. Okay? So now, write it as an expression that makes sense to you. 85 divided by 7 equals 12 remainder 1. Okay? That's fine to do. Now, how do we check that to make sure that it's correct? Okay? Especially if we don't have a calculator that will show us what the remainder is, and a calculator that will only show it as a decimal. Okay, so this is what you do. So you're going to multiply 12 times 7 plus 1. Okay, this is called multiple operations. Okay, and it's a little bit more advanced, obviously, for my third graders, okay, but this is showing what the inverse operation is. If this equals 85, then we're good. It's correct, okay? So 12 times 7, 7 times 10 is 70, 7 times 2 is 14, 70 plus 14 is 84. So I just used some partial products there. 84 plus 1 equals 85. Okay? So that's using the inverse operation here in order to solve this problem. So now you can see why it's going to be a little bit more advanced for your third graders. Okay, that's a message to my class and their parents. But you can see how it would work out. It does take practice. Okay. What I suggest, parents, if you have younger kids and they're just learning this, is to give them problems that do not contain a remainder at first. The remainder is going to kind of confuse them. So let's look at some problems where you would not need a remainder for those younger kids. Let's do something like this. Okay, set up a problem like this. A 2-digit number divided by a 1-digit number. You can think of it like that as well. And if you needed to write it over like this for your child who's a beginner, so they can understand it, if this is what they're used to, they can see it that way. That's fine too. Maybe have them use a friendly number like I did here. Okay, so I can use the friendly number of 10 once again. 10 times 3 is 30. 66 minus 30 is 36. I didn't have to borrow. Okay. Now I'm going to use another friendly number of 10. 10 times 3 is 30. 36 minus 30 is 6. One times 3 is 3. 6 minus 3 is 3. 1 times 3 is 3. 3 minus 3 is 0. Add up all your partial quotients. 10 plus 10 is 20. 20 plus 1 is 21. 21 plus 1 is 22. With no remainders. Okay? 66 divided by 3 equals 22. Okay, this right here, this strategy, the way I set it up, just setting up the problem, is good for a beginner. Why is it a good for a beginner? Why? Okay. Because when you subtract, okay, there's no borrowing. And of course, there's no remainders. All right, so those are some ideas for how to get a beginner involved in the partial quotients. Okay, another friendly number they could do once they get more advanced is, okay, 20 times 3 is 60. 60 divided by 6 is 6. 3 times 2 is 6. 20 plus 2 equals 22. Okay, just a thought process here. I'll share a little game that I used to play when I was learning this strategy as a teacher. Okay, so I used to, in traffic, if I was at a red light, I used to like to play the red light game in traffic. And if I'm ever, whenever I feel like playing this game, I try to do it mentally. Okay, red light traffic game. So let's imagine that I was in a car and there's a car in front of me. Okay, I would look at their license plate, and let's say their license plate said something like 654. You know how license plates in the US look like, JKL or something like that. Let's just imagine. Okay, so in my mind, what I tried to do is I tried to divide this by the time the light turned green. Okay, so that was something that I tried to do. So in my mind, it went like this, see? After practice, I could kind of envision that. And I had to be quick because you wanted to divide this and figure out what the answer was before that light turned green and the car was off and then I couldn't see it. In fact, there's probably been times when I've actually followed the car a little bit longer than what I should have if I couldn't get it in time, okay? I'm not going to admit to that though, but maybe. Okay, in this case, if you see it like this, then you can just think, okay, 9 times 6 is 54. And then in my mind, I would say, okay, 54 divided by 6 equals 9. Maybe even say the whole fact family. Okay, if you really want to challenge yourself. The red light traffic game. And that was just something I invented just because I was bored in traffic sometimes. Take that license plate and just imagine it as a division problem, just the numbers itself. It was fun. I don't do that so much anymore because I don't teach partial quotients, but I always can if I'm bored in traffic. Okay. Let's work on some more difficult problems. All right, let's go ahead and get into the hundreds. 387 divided by, say, a 2-digit number. Let's say 20. Okay. In this case, what I would like to do is actually use what's called an estimate. So I know that 20 times 2, okay, is going to be 40. So 20 times 20 is 400. That's very, very close to this number here. Okay, so I want to estimate. If 20 times 20 is 400, okay, and it's close to 387, then 19 is going to be a great estimate for the first number that you're going to multiply. In fact, the number is going to be 380. I know that 19 times 20 is going to be 380 because 20 times 20 is 400, and if I take another 20 away, it equals 380. So obviously this is going to be, right, you can tell this is going to be more advanced. But obviously it's possible. So now all I have to do is subtract 7 minus 0, and I got my answer. Remainder 7. Add those partial products together. 19 remainder 7. Okay. 387 divided by 20 equals 19 remainder 7. $20 times 19 plus 7 equals, okay, so I'm going to use that remainder here. These are multiple operations once again. I know that 20 times 19 equals 380. And I know if I add 380 plus 7, it's 387. And now that's my dividend once again. Okay, so I'm going to use a calculator just to show that 20 times 19 equals 380, just so we can check. Okay? So that's going to be a more advanced strategy there, but that's how you can solve something like that quickly using partial quotients. And of course, this is not going to be for your typical third grader just to jump into, okay? In fact, when I was teaching fifth, you know, some advanced students could get this, but it took time still. It's not easy. There's a lot of understanding of all three of the operations in order to solve this problem. Okay, different strategies too, like estimation. Okay, so let's go ahead and work with different numbers. I like to work with well, let's see, let's work in the thousands now. Okay, so we'll do 6,480 divided by, what can we say? How about 30? 32. Okay. Now, you may be looking at partial quotients saying, you know what, this is confusing for me. You know, I learned long division and I can do long division really well. Well, you still kind of use some of the strategies for long division in order to figure this out. You still do, okay? You're still looking at these first two digits here to try to figure out a good estimation. I know that 32 times 2 is 64. Okay, now I can go ahead and use a decent estimation for that, just with that knowledge that I have there. Okay, so what I'm going to do is try to extend my basic facts into the thousand. I know 2 times 32 is 64. Therefore, 20 times 32 is 640. Therefore, 200 times 32 equals 6,400. $200 times 32 equals 6,400. So 6,480 minus 6,400 is 80. I'm going to use 2. 2 times 32 equals 64. Okay, rather than borrowing, which I prefer not to, I'm going to count up. 64 plus 16 equals 80. So I know that's 16. At this point, you can even turn this into a decimal, okay, if you'd like to. So I know that there's a remainder of 16. So I'm going to add this up. 200 plus 2 equals 202, remainder 16. Okay. I do want to do one multiplication problem here on my calculator just to check. And I want to do 32 times 200 to make sure that this first partial quotient was correct. And it was. Okay. All right, so at this point, double check your work. 32 times 202 plus our remainder of 16 So 32 times 202 equals 6,480. That can't be right. 6,464 plus 16 equals 6,800. Okay? And let's see if that's true. I like to use a calculator with these higher numbers. Plus 16 equals 6,480. So now we're back to our now we are back to our dividend. Okay? Remember what I always say about math, okay? And this is kind of my motto. I actually came up with it yesterday when I was making a mental shift. If you take out, if you look at ways to multiply partial products, when I was making that shift from partial products to the standard multiplication algorithm, okay, that shift in my brain didn't happen right away. Okay, so this is kind of what I came up with as a motto. Precision, not perfection with numbers. It's very important. Some people, especially perfectionists, and I struggle with that too a little bit, but I'm very mindful of it, okay, is that perfectionists want it to be perfect the first time. Like if you saw me make that mistake right here with 6,800, but if you notice I just laughed it off, I checked the work, and I reminded myself that precision, not perfection with numbers. Okay, perfectionists aren't going to get very far with mathematics because there's going to be plenty of mistakes. So try to keep that in mind. Now, another thing that I think is cool here is if I'm looking at this here, all right, I can actually, this is for the advanced mathematics. So 202, I can actually express that as 202.5 as a decimal. for the answer. And I know that's true because 202 16/32 is equal or equivalent to 202.5 because 16 is half of 32. And any half equivalent is going to be 0.5 as a decimal. So we can express this as a fraction of a number, even though we're not actually dividing into it. Okay? And we can write any division problem like this, where we have the remainder on top of the divisor. Okay, so for example, with this problem right here, I can also express the answer as 19/7/20 if I wanted to. That's okay. And this answer is also correct. Now, if you don't have a good, numeric foundation, all right, especially with your basic operations, then this is going to be a difficult concept to understand. Okay? So now let's go ahead and just double check to see if I'm correct here with the decimal. And in third grade, we don't even get into decimals, parents. Okay, we don't get into them, and that goes out to my class. All right, because my class views my YouTube videos. But by the time they're in probably fifth grade, definitely by middle school, then they're starting to work with fractions. So let's see if I was right. And this is a decimal equivalent. Okay, so 6,480 divided by 32 equals 202.5, see? I do not recommend that, if you're a beginner, but obviously this is going to be a more advanced way to be able to understand that. But of course, you have to understand how to divide fractions, okay, in order to be able to understand that. But don't worry about that at this point. Good. Okay, so that's the partial quotients strategy for division. So just like in all my videos, if you watch them, we go over the pros and cons of each strategy that I teach, each of them. Okay, so now let's talk about those pros and those cons of the partial quotients. Pros. Cons. The pros are that you are flexible with numbers. The cons are that you have to know your operations. Okay, and remember what operations are in mathematics. Okay, it's going to be your addition, subtraction, multiplication. If you're not proficient with your operations, then this is going to be very difficult, incredibly difficult. Okay? Pros here are that you can do it mentally. And believe me when I tell you you can. I can do it mentally. It does take, the higher the numbers get, the more difficult it is, without a doubt. But it is possible. Okay? The cons are it can be confusing. And difficult for beginners. Nonetheless, I did share some strategies how you can get beginners involved is by using lower numbers. Okay, try to avoid remainders. Maybe do like a 2-digit number divided by a 1-digit number. Okay, and if you set up a problem for a beginner, all right, make sure that, and I'll put this here once again, if you set up a problem for a beginner, no borrowing with the subtraction, because that's one more step that they need to be able to get the problem. And if they're not proficient with their other operations, they won't be able to do it. It's just as simple as that. Okay? Set up a problem where you can avoid borrowing. Set up a problem where you have no remainders. Okay. And try that red light traffic game if you can. I think it's cool. That's actually how I became proficient at this strategy, because if you really think about it, okay, if especially in the United States, I know some of the viewers are outside of the United States, but that's how our license plates look. Okay, it has like a three numbers followed by 3 letters if it's not customized. Okay, and you just do little tricks like this and you'll become proficient, I guarantee it. Okay. And plus it's just something fun to do in traffic while you wait around on a red light. Okay, the next strategy we're going to use is the